Okay, so you know how sometimes you're trying to pull info from a website and you hit that dreaded 403 forbidden error? Well, turns out a bunch of you have been struggling with this, specifically when it comes to web scraping. And you flag this super in-depth guide from Nick Webson over at Rebrowser, really digging into how to get around these roadblocks.
Yeah, and what we're going to unpack today are the reasons why these keep out signs pop up in the first place and the most effective ways people are using to get past them. It's all about getting that online data you need and staying ahead of the game, right?
Right. And just to be clear, we're not going line by line through some technical manual here. We're pulling out the juicy bits, the stuff that makes you go, oh, that's how it works. It seems like websites are upping their defense game big time.
Oh, for sure. And this guide makes it crystal clear those old tricks just won't cut it anymore. These anti-bot systems are getting seriously advanced.
So let's start with the basics, that 403 forbidden message. What's the server actually telling us when we see that?
Well, the server gets what you're asking for, it understands the request, but it's like, nope, not happening. In the context of web scraping, this means the site's defenses have spotted your bot and they're shutting you down.
And it's a huge problem these days, right? The guide throws out this wild stat. Over 70% of website traffic is now automated.
I know, right? It's mind-blowing. And that explains why websites are going all in on protection. With that much bot activity, they have to defend against all sorts of things. Malicious bots, data theft, server overload. It's a battlefield out there.
So what are the usual culprits that trigger these 403s?
Let's see. The guide breaks it down into a few key things. First up, basic bot fingerprinting. This is where the site looks for those obvious signs you're not a real person using a normal browser. Then there's IP-based rate limiting, where you get flagged if too many requests come from the same IP address in a short period.
Makes sense.
Then you've got browser fingerprint analysis, which is way more in-depth.
Yeah.
They're looking at the specific settings and characteristics of your browser setup. It's like a digital fingerprint. And then there's behavioral pattern detection. This is where things get really interesting. They analyze how you interact with the site. Are you clicking and navigating like a real human, or are you following a rigid automated pattern?
I never thought about that.
Oh, yeah. And finally, there are those JavaScript challenge failures. You know, those little puzzles you often see to prove you're not a robot. Well, regular browsers solve those easily, but basic bots get tripped up.
Websites have a whole arsenal of tricks up their sleeves. And this guide mentions things are getting even tougher, especially with companies like Cloudflare leading the charge.
For sure. The guide goes deep into how Cloudflare rolled out some serious upgrades to their protection mechanisms just last year in 2024. They're using machine learning now to analyze behavior, which means they're way better at spotting the subtle differences between humans and bots.
So it's getting harder and harder to fly under the radar.
Definitely. And they've also stepped up their device fingerprinting game, looking beyond just the browser. And those JavaScript challenges are way more complex now, designed to really throw off automated solvers.
Okay, so the bar is getting higher. So how do we actually get past these barriers? The guide stresses the importance of a multi-layered approach.
You got it. No more silver bullets, unfortunately. You need a combination of advanced techniques to really make a dent. And the guide lays out some key strategies.
Let's dig into that. So advanced browser fingerprinting, it's not just about changing the user agent anymore, right? What else are these sites looking at, and how do we adjust?
Exactly. They're now combing through a ton of HTTP headers that your browser sends with each request. And you know what? The guide even has a super detailed example of what a well-configured set of headers should look like.
So what are some of the big ones they highlight there?
Well, there's the user agent, which we mentioned, that identifies your browser and operating system. But then there's accept, which tells the server what kind of content your browser can handle, HTML, images, videos, that kind of thing. Then you've got accept language, showing your language preference.
Yeah, starting to get the picture.
And there's accept encoding for the compression methods your browser supports, like gzip or burr, which helps speed up loading times. Connection is often set to keep alive to keep that connection going for better efficiency. Upgrade insecure requests signals that the browser prefers secure HTTPS connections.
Wow. It's way more than just a user agent.
You said it. And then there's this whole series of secfetch headers, secfetch dest, secfetch mode, secfetch site. These give the server more context about where the request is coming from and what it's trying to do. And finally, Sexua Mobile, and Sexua Platform offer super detailed info about the user agent. Setting all of these to match a real browser is key to avoiding detection.
It's like building a convincing disguise for your bot. The guide also talks about intelligent proxy rotation. We all know about using proxies, but what makes it intelligent?
The big difference is moving beyond just cycling through a list of IPs. Intelligent proxy management involves a few key things. First, using geographically appropriate proxies. If you're scraping a site that mainly serves users in, say, France, using French proxies makes your requests look way less suspicious.
Right, blending in with the crowd.
Exactly. And maintaining consistent sessions is important too. Instead of jumping to a new IP for every single request, try sticking with the same proxy for a sequence of actions. It looks more natural.
Like a real person browsing.
Yep. And automatic proxy health checking is essential. You got to constantly make sure your proxies are working and haven't been blocked. And finally, rate limiting per proxy. Even with a ton of proxies, if you overload one with too many requests, it'll get flagged.
The guide even has a code snippet for a smart proxy manager. What's the gist of how that thing works?
That code really shows the heart of intelligent proxy management. It tracks two main things for each proxy: when it was last used and how many recent failures it's had. Before picking a proxy for a new request, this smart proxy manager checks if enough time has passed since its last use to avoid hitting rate limits.
Right.
And it also checks if the proxy has too many recent failures, which means it might be blocked or unreliable. Then it picks a proxy that has the least recent failures and was used the longest time ago, making sure you're using all your proxies evenly and carefully. There's even a mind delay setting to help with that per proxy rate limiting.
So we're making requests look like they're coming from different legitimate browsers in different locations and not overloading any single proxy. What's the next layer the guide talks about? I think it mentions JavaScript rendering.
Yeah, this is getting more and more crucial because so many sites use JavaScript to load content and run their security measures. If your scraping tool can't run JavaScript, you'll miss out on data or get caught by those JavaScript-based checks. That's where tools like Playwright come in. The guide actually gives a code example for this.
So how does being able to render JavaScript help with those 403 errors?
Playwright is a super powerful browser automation library. That Scrape with JS function in the guide launches a full Chromium browser behind the scenes. This lets you set things like viewport size and user agent, go to the target URL, and most importantly, wait for the whole page to load, including all that JavaScript-generated content and any security challenges that pop up. There's even a line in the code, page.waitfortimeout 5000, that gives the page a few seconds to deal with those challenges.
Clever.
Only after the page is fully loaded does it grab the final HTML content. By working inside a real browser environment, you're way more likely to bypass those JavaScript-based defenses and solve those tough challenges that simpler tools can't handle.
So it's like using a real browser, just controlled by code. Besides these technical solutions, the guide also mentions best practices for keeping your scraping operation running smoothly.
Absolutely. It's not a one-and-done thing. You need to monitor and adapt constantly.
What should people be keeping an eye on if they're scraping regularly?
The guide recommends a few key things. You got to track your success rates on all the sites you're scraping to catch any sudden drops or blocking patterns. Monitoring your proxy performance is crucial too. Are they staying up or are they getting blocked a lot? And looking at the patterns of failed requests can give you clues about why you're getting blocked, so you can adjust your approach and stay ahead of the curve.
Makes sense. Now, the guide also talks about community insights, getting a feel for what other people are saying about tackling these 403s. What's the word on the street?
It's pretty interesting. There's a growing consensus about the power of randomization, not just with proxies and user agents, but with your scraper's behavior itself, like putting in random delays between requests, following different timing patterns, that kind of thing. It makes your bot look way more human.
Like it's actually a person browsing.
Exactly. There's also debate about how complex your header modifications need to be, but everyone agrees that using multiple techniques together, that layered approach, is more important than ever. And there's a clear shift towards using more powerful tools like Selenium, Playwright, and even specialized scraping APIs because the whole landscape is getting more complex.
And the guide has this great case study about an e-commerce company battling these exact issues.
Yeah, that's a real-world example of how effective this multi-layered approach can be. They were having major problems with 403 errors when trying to scrape competitor prices. So they implemented a whole system with sophisticated browser fingerprint randomization, residential proxy rotation, and what they called request pattern naturalization, which probably meant making their requests look more like normal human browsing.
Did it work?
Big time. Their success rate jumped from a measly 45% to a whopping 92%. Plus, their cost per successful request went way down, and they had less maintenance overhead. It really proves the value of a well-planned, multi-pronged strategy.
So basically, dealing with 403s these days is a constant game of cat and mouse. No more easy wins.
You got it. You need a comprehensive and adaptive strategy. Basic stuff like rotating proxies and spoofing user agents is still important, but you have to step it up with advanced browser fingerprinting, intelligent proxy management, and being able to handle JavaScript rendering and those tricky security challenges.
And staying ahead of the curve is key, because these anti-bot systems are constantly evolving.
Absolutely. Keeping up with the latest technologies and adapting your methods is the only way to win this game in the long run.
It makes you wonder what's next in this whole back and forth between data gatherers and website protectors. What new innovations will we see? It's a constantly evolving field. If you're curious about any of the specific tools or tech we talked about, the guide recommends checking out the official Playwright documentation and the Cloudflare Learning Center. Great places to dig deeper. Thanks for joining us for this deep dive.